reduce number of outbreaks by predicting risk. So I wonder if this patient has a risk for this virus. And how could we get that answer? With statistics, you can use the historical information, and here we could find that the red group is the one with the disease. And I wonder what kind of characteristics these people has and how they differ from the rest that is more healthy. I get the information and I can use this information to find out if this patient has almost the same characteristics, because then we can have a score like 80% score that tell us that this person has an 80% risk to get this virus. All these scorings is something that you can get, and the methods for that could be, for example, logistic regression or decision tree. Here's an example of decision tree. So what you get is automatically a tree from all your information you have about the patients, and this tree will explain for you the most important characteristics for the people who is more sick. Then the next example.
So start with the first one. Which students like each other? And how could we from that create the most optimal project groups? So if we start to just study all the students, they have a lot of characteristics, and just put in all these characteristics or variables into SPSS. Then you can get help to group these. And in this example, we get 3 groups. So in group 1, we have similar people due to some characteristics that I have chosen. In the yellow group, we have another characteristics that is in common in this group. So what you do then is to, for example, choose one from each group. So in the end, you will get one from group 1, one from group 2, and one from group 3. And that means that you have 3 quite different students. And that could be a good idea to get them together to create a project group. The method behind this is cluster analysis.
The databank began collecting information on patients who underwent heart catheterization at Duke beginning back in 1969. It since that time has collected routinely that information, upwards to 85,000 patients over the years. This makes it the largest ongoing longitudinal registry in the world. SAS was the ideal partner for Duke to work with on this. SAS has the tools that we use to analyze data every day in our large clinical trials. But SAS has also made a protected environment that allows us to analyze this data in a way that protects patient confidentiality, assures that high-quality research are being done, but then allows us the analytic tools to make sure those answers are correct. It's our goal that will allow the Duke Databank now to be opened up to researchers around the world, so researchers who have good questions can ask questions of that data, analyze it in a protected environment, and ultimately make discoveries that hopefully will help heart disease patients in the future.